Today we continue our discussion of the universe with a focus on the planets. Alright, so as we were talking yesterday, we discussed this idea that the leftover stuff from the making of a star is what eventually gets pulled together by gravity, and as these pieces bump into each other, they begin to stick and create these planets. So before we go any further, make sure that you have the documentation open for today. Now the file that's attached to today's lesson is the same as the one attached to yesterday's lesson. That doesn't mean you have to fill it out twice. It just means that yesterday you should have filled out all of the information about the universe, and today you only need to fill out, on today's version of the document, you only need to fill out the information about the planets. So have that open on your desktop and set it up so that you can maybe see both your document and the movie here, and you can just follow along and fill it in as we go. So usually the items that are in red in the video, things like leftover stuff from making the star and the word gravity, would go on some of the blank lines in your guided notes document. So let's talk about some planets rather. So there are basically two different types of planets that could possibly arise from the leftover remnants of stars when they're being created. And those are rocky and gaseous. So let's start with the rocky planets. And I'm going to real quickly here open up the document as well so that I can follow along, make sure I'm hitting all the high points. Wrong one. There we go. Alright, so you're going to start from right here. Planets are made from. This comes right after the what three things can a star become? And you should have filled that in on your own. So any blanks that you didn't hear me cover would be things that you should be able to figure out from either the video slides that were in the video, or from something I said, or putting 2 and 2 together to make 4. So you're going to be starting from, what are planets made from? Well, they're made from either rocks or gas. And what force starts planets forming? That would be gravity. Alright. So what is the first type of planet? Let's get into that. First type of planet, of course, is rocky. They tend to be smaller in size, and they're usually closer to the star, though that's not always the case. So usually rocky planets are pretty close to the star that their material came from, and they tend to be smaller than the gaseous. And in our solar system, the rocky planets would be Mercury, Venus, Mars, and of course our own planet is obviously rocky. We studied the lithosphere already, right? So that would be Earth. The second type of planet, as I said, is the gaseous, and of course it's made out of gas. So these aren't very tricky names, they're pretty straightforward, so that's a good thing. Makes it a bit more easy to remember. and they if you go to a gas planet, it's going to be kind of difficult to hang out there because there's nowhere to stand. There's no rock to stand on. You can't stand on gas. You'd float right through it. In other words, gaseous planets tend to be very, very large. In fact, they are almost a star. They're just not on fire like a star. They're not burning. And these typically are located far away from the stars that gave them birth. Alright, so that's pretty much all we're going to deal with in terms of planets. So the other planets in our solar system that we didn't mention in the previous slide would be gaseous planets. So for instance, you'd have things like Neptune and Uranus and a couple others that would be gaseous planets in our solar system. But most planets also have moons. And moons are basically very small versions of a planet that orbit another planet. So moons can be really, really big, or they can be very small. And this, of course, is relative to the size of the planet that they're revolving around. And the other thing about moons is we probably have the misconception that moons are always round, but they're not always round. They're not always a perfect sphere. You can see in the image on the left that they all look pretty round, except for maybe this one right here and this one right over here may not be quite round, but they all look pretty round. But they're not always that way, so just be clear on that. So we're going to talk about some specific moons, ones that are significant either in size or shape or what they're made of or where they're located. The first moon we want to talk about is Io. Here's the name of the moon right here, Io. And this is the first moon of Jupiter. It's the fourth largest moon in our solar system, and it's covered in 400 volcanoes that we've been able to count. This thing stinks. I mean, it just stinks, this moon. It smells like rotten eggs because a large portion of it is made up of sulfur. And the mountains on the surface of this moon are actually taller than the mountains we find here on Earth, including Mount Everest. So, in your worksheet, on your worksheet, you have some blanks. It says it's covered in active, that would be volcanoes. Lava actually gets thrown from these volcanoes for hundreds of miles. Literally. These volcanoes put out a lot of smoke and sulfur. There are over 400 of these volcanoes. And I can't remember the name of the one that's the biggest volcano. Let's see if I can look it up real quick. I used to know this. Okay, it's Loki Patera. Loki Patera. L-O-K-I, and then another second word, P-A-T-E-R-A. It's the largest volcanic depression on the moon. It contains an active lava lake. Okay. Let's go to the next moon. I think we covered all the details for Io. Oh, well, the eruptions are so big because Io is so big. Alright, next we've got Titan. So this is the second largest moon. It's actually bigger than Io, because Io is the fourth largest moon. And in fact, it's bigger than Mercury. So Titan is one of the moons for Saturn, and it has an atmosphere very similar to Earth. It's a pretty dense atmosphere, and in fact, there is some evidence that there may have been stable bodies of surface liquid. Now that doesn't mean water, it just means liquid. It's mainly composed of ice, and it actually rains there just like it does here on Earth. But unfortunately, it wouldn't be very fun to be in a rainstorm there because the rain is made out of natural gas. Yuck. So, on your worksheet, Titan is the only moon with an atmosphere and rain. The temperature is about negative 179 degrees Celsius, so it's extremely frigid there. The liquid is mostly natural gas, or nitrogen actually. What is missing from Titan's lakes? Well, that would be water. Alright, and again, it's the largest moon of Saturn. Alright, the next one we're going to talk about is Europa. Alright, so Europa is covered in ice. That's water, so it's a big ball of ice. It's got cracks in it that go for hundreds of miles. It might have water underneath the ice, but we're not sure. Seems to be there's a liquid under there. So scientists are hopeful that they can find water on a planet or a moon somewhere, because if there's water, there's a potentiality for life. Okay. It is one of Jupiter's moons. It's actually one of the smallest moons of Jupiter. And Galileo found it back in the 1600s, like 1610, somewhere around there. And it's mostly made of silicate rock, but it does have this water ice crust. It has a very smooth surface. This is what has led to the hypothesis that water might exist underneath that ice. Alright. So there's tectonic activity is one of the things that's going on there. Tectonic activity. But the tectonic activity is with the ice, though. The ice is moving probably because of some tidal flexing. If there is water underneath that ice, could be causing the ice to move a little bit. So that's some of the activity that we see there when I talk about tectonic. It's really isonic, I guess, if that's a word, which it isn't. We see some water vapor plumes. So it looks like they're basically erupting geysers. And so they're frozen, though, so it'd be like cryo geysers, right? So signs of activity would be ice movement, and the second one would be geysers. Okay, so the next blank is we think there might be what? We think there might be life on Europa in the ocean. It wouldn't look like us, of course. It might just be single-celled organisms or something like that, because it would need to work without oxygen. There is no oxygen on that planet. Many places Europa looks just like the mountain ranges on Earth. Let's back up one. Forgot to fill that one in. And oh, there's a question there. What force starts stars and galaxies? Quick review. Hopefully you just said gravity. If you did, you're right. Alright, next moon is our own. In terms of the worksheet, but for some reason it's missing. And we just call the moon around the planet Earth moon. Very fancy name. I know. Alright, so the moon orbits at a distance of how many miles? Does anybody know? Well, it's about 238,900 miles, or as we scientists like to say, 384,400 kilometers, or 1.28 light seconds. The moon's thought to be about 451 billion years old. So that was shortly after the Earth formed. It would have formed, according to the current hypotheses. But they think that our moon formed from a gigantic impact between the Earth and a Mars-sized body called Theia. So this would have broken off a portion of Earth to help form the moon. but then the Earth is pretty round, so not sure if that's really true. But it could be. I don't know. I'm not an astrophysicist, so what do I know? Okay, what else does your worksheet want to know? Many cultures thought the moon was a deity or a god. And then the Earth was hit by an object the size of, what did I just say? Did you catch it? The size of Mars. The leftovers from that hit made the moon. So the moon always shows the same side. We never see the back side of the moon. It's rotating around us, and as it rotates around us, it spins in that same direction. So we always see the same face of the moon. And there may be craters on the moon from comets. Well, there are craters on the moon. The moon's gravity is much less than that of Earth's, so you would weigh quite a bit different. The amount of gravity on the moon is we would call that the gravitational constant of the moon. The gravitational gravitational constant on the moon is 1.622. So in order to determine mass, we would take volume let's see. So to find out what your weight would be on the moon, you would take your weight and divide it by what I just said, 1.622. So if you, let's do one. So let's say you weigh 150 pounds. So it would be 150 divided by 1.622. That would be, I need a calculator. Alright, so 150 divided by 1.622 equals 92. So on the moon, you would only weigh 92 pounds, not 150. No, I think I did that wrong. Actually, what you would need to do is divide it by Earth's gravitational constant. Alright, so let's put that in parentheses because then we're going to multiply it by the moon's gravitational constant. And multiply by 1.622. So you would be 24 pounds, 24.8 pounds on the moon. Okay, so you divide your weight by 9.8, which is Earth's gravitational constant, and then you multiply that by 1.622, and you should come up with, if you start with 150, you should come up with 24.8, or 25 basically. Okay, that's how you do that. Alright, so the rest of it is now getting into other parts, which we'll talk about that tomorrow. So we'll save the rest for tomorrow. Should be a shorter video tomorrow. Okay? And we'll finish up our packet tomorrow. Alright.